What follows is a description of the Kegelfin airflow device, or KAD. The KAD utilizes the Coandă effect to increase the ambient air pressure in the zone immediately behind the trailer when it is in motion. In other words, the zone outside of the closed trailer doors is pressurized. This phenomenon reduces the energy, gas, diesel, or electric, needed to move the trailer and keep it in motion. This is a close-up view of the belt guard on the rearmost trailer wheel. This is the left wheel. The right wheel also has a belt guard on the other side of the trailer. Here we have a close-up view of the left side turbine with its two drive belts. The left belt guard is shown with a semi-transparent material as a visual aid. Two drive belts are needed, just in case there is a failure of one. This is a close-up view of the left turbine mounted to the left vertical air column. The grill, shown in this image, prevents debris from entering the air column as the turning turbine draws air into the vertical air column and pressurizes it. The area above the grill is the active or functional part of the air column. The triangular part of the air column is used for mounting it to the trailer. The right air column, not shown, is similar to the left vertical air column. Another view of the vertical air column on the left side. The orifice or slit highlighted here is where the pressurized air in the column discharges. The discharging air moves along the curved surface of the air column due to the Coandă effect. This is a close-up view of the top portion of the left vertical air column. Note at the top of the column, it is closed to enable pressurization of the column. The large hole shown is for tool access to bolt the column to the trailer. This is a close-up cross-sectional view of the left turbine mounted to the left vertical air column with the belt guard installed. Here we have another look at the same cross-section view. This is the wheel gear that drives the turbine. There is one wheel gear on each rear wheel, left and right. These gears drive the left and right turbines. This is a secondary view of the wheel gear. It shows the 6 holes that are used to mount the gear to the wheel. This illustration shows the left wheel gear mounted to the rearmost trailer left wheel. And here a cross-sectional view of the wheel gear on the left trailer wheel. This is a free body diagram illustrating the drive belt system with its tensioners in the normal state of operation. Normal state is when the trailer is moving along a smooth, even surface. As the road conditions change, the distance between the center lines of the turbine and the wheel gear hub changes. Now we have a free body diagram illustrating the drive belt system with its tensioners when the trailer is driven over a bump in the road. The distance between the turbine and the wheel gear is reduced. And an additional diagram of the drive belt system with its tensioners when the trailer is driven over a pothole in the road. The distance between the turbine and the wheel gear is increased. This picture shows the belt path when mounted to the turbine. Includes the wheel gear with tensioner wheels to keep the belt taut. The rotational speed of the turbine when the trailer is traveling at 100 miles per hour is over 15,000 RPM. This high rate of revolution is due to the 18:1 ratio between the wheel gear and the turbine. This illustration shows the dual belts mounted to the turbine and wheel gear with the belt tensioners. The inside of the belt guard is also shown. Here is a close-up view of the belts on the left wheel gear with the tensioner. The belt guard is shown with semi-transparent material for visual aid. A ball slide, which is used to facilitate the changing centerline distance, is also shown. The ball slide, green, is mounted to the wheel gear and the belt guard. This is a close-up view of the belt tensioner on the dual belts. And we have a close-up cross-sectional view of the belt tensioner. This is the ball slide assembly, which enables the changing distance between the wheel gear center line and the turbine center line. The bolt that connects the slide assembly to the wheel gear is shown. The bottom part of the wheel assembly, gray, is bolted to the belt guard. This is the only electronics on the KAD. It is the Belt Presence Detectional System. The system comprises of a battery holder, LED sensors, and a printed circuit board, PCB. The components are connected with a wire harness. The two pairs of LED sensors are aimed at each other. The two belts are routed in the pathway between the sensors. If the belts are in good working condition, the sensors cannot see each other. If a belt is broken, then the sensors can see each other. When the sensors can see each other, this is a fault condition. The fault condition triggers an audible and visual alert. The cover for the circuit board is a part of the system for dust and debris protection. This is the belt guard with the belt presence sensor shown. Here a close-up view of the belt presence sensor. When the clear LED is illuminated, the system is working as intended. When the yellow LED is illuminated, the system's battery is weak and needs to be changed as soon as possible. When the red LED is illuminated, a belt is broken and must be replaced as soon as possible. This is the belt presence failure alert system that is placed in the tractor cab. The alert is audible and visual with red LED. The system is connected to the main belt presence system via Bluetooth. This is a view looking at the rear portion of the trailer, showing the left wheel gear and left turbine pulleys. This is a view of the rear of the trailer with the KAD installed. Here an illustration depicts the rear of the trailer without KAD installed. Note the ambient pressure conditions on the rear of the trailer. Here the illustration depicts the rear of the trailer with KAD installed. Note the ambient pressure conditions at the rear of the trailer. As the trailer moves, the KAD is activated and the pressure in the zone behind the trailer increases. The increased pressure results in reduced fuel consumption. Please take a moment to watch this video on how the Coandă effect works.